Okay, can everybody hear me? Oh.
Yes, we can.
Marvelous. Okay, hello, it is once again I, the disembodied voice. The call is coming from inside the house. This is the debplate talk by Ben Hutchings, so welcome him.
Hello, so today I'm going to be talking about a project that I've been working on for a couple of months by myself so far. It's a template system for Debian packages, and I'll explain what that means in a moment. In case you don't know me, I am Ben Hutchings. I've been working on Debian since about 2005, and most of that is concentrating on the Linux kernel packaging and related packages. So, why would you want to use a template system for your source package, and what does that actually do? Suppose that your source package builds multiple binary packages, and they need to be similar. They need to be consistent. For example, if you have an application that has a number of plugins that are optional, and they have perhaps have a lot of dependencies of their own, you could split those out into multiple separate packages, and those plugins, the packaging of those plugins should be should be similar, should be consistent across all the plugin packages. You might be building server software that for some reason you want to offer linked with either OpenSSL or GNU-TLS. Again, apart from that shared library link dependency, they're going to be pretty much identical binary packages. You might be packaging a compiler, and you want to build a native compiler, but also cross compilers for different targets. Again, the binary packages should look very similar. And if for any reason you need to have multiple build configurations that are useful on different systems, obviously this is important for the Linux kernel packaging. Sometimes a single configuration isn't suitable for all for all computers that use a single architecture. Another reason why you might want a template system is when you have frequent API changes, and those will require changing the package, the binary package name in multiple places. And in general, there's a good principle of software development, which is don't repeat yourself, and a template system can help to avoid that repetition. So this is a problem that there are lots of packages that can benefit from a template system, and of course this has been done before. The kernel team has had a template system for many years. It's relatively, the template substitution itself is relatively simple, but the result of that is we need a lot of custom logic as well as the templates and variable definitions. The GCC and GCC defaults source packages also have a template system. It's, so far as I could see, it's even more limited than the kernel team's one. I found it quite hard to work with when doing a GCC defaults package. There are probably others in use, but I didn't find any general tool for this when I looked, so I started writing my own one. debplate is intended to be a general tool. It's intended to be usable by any source package that needs a template system, and if it is generally usable and is adopted, then hopefully those packages will be less unusual, and it will be easier to work on those for contributors that aren't the regular maintainers. So currently debplate can generate the Debian control file and Debian tests control. It can generate a makefile that would be included in Debian rules. It doesn't generate Debian rules because actually we want to have a static Debian rules to make it easier to invoke debplate. And it can generate per package configuration files, which are used like those used by debhelper. So, list of examples there. Basically, any text file that starts with the package binary package name can be generated from a template. So here's an overview of how you would create the files to make debplate work. So this example package is using DH, and it has the standard wildcard rule for running DH, and we just have one extra line in there to include a makefile that's provided by debplate, and that will ensure that the debplate is run at build time to generate the additional required files. Debian control and Debian source control, Debian tests control, of course, have to exist in the source package, so those would be generated separately. Then you have configuration file, Debian debplate config.yaml. So that's, as you can see, a YAML file, and that would have all the variable definitions in it, and it would specify groups of templates to be expanded. And the templates themselves would then exist under currently in the subdirectory Debian templates. So this is what the configuration file this is a larger part of a configuration file for debplate. Everything is organized into groups. This top level group, which may or may not contain packages. In this example, we have two groups under the top level called foo and bar. Both of them are applying the binary as a collection of templates called binary, and they'll have different variables that will be used in those templates. And so here's the binary.control template that would be used for that. That generates the binary package paragraph for a single package. I don't know if you haven't recognized this syntax yet. This is Ginger template. So the simplest substitution is put a variable name in double braces, and we've got some more complex use here to do word wrapping of the description, and then you have a conditional section there. Beginning with open brace %if, and you can also there are also various filters you can use. You'll see on the recommends and suggests fields that they reference the recommends and suggests variables. The suggests variable is not defined for foo, but that's okay because we apply a filter there called default, which can be used to provide a default value if the variable isn't defined. The Ginger configuration that I've used makes undefined variables an error. So that hopefully if you make a typo, that will be caught, and you need to explicitly provide a default. And there are lots more features that I haven't shown here. Groups can have child groups down to any depth. I expect that won't be needed by most packages, but in the kernel we do have feature sets which involve applying extra packages to the source, and also flavors within that. And then we have architecture-specific settings as well, so we would need that. Variables are inherited in child groups, but they can be overridden or extended if necessary by the child groups. It's also possible to specify that a set of templates that should be used in descendant groups, so that you don't have to repeat the list of templates in multiple places. You can restrict a group to be built on only specific architectures, rather than putting that architecture restriction in multiple binary package templates. You would apply it to the group. You can disable a group completely, which I think obviously you could completely delete a group, and that would prevent building those packages that the group describes. But if someone's maintaining a derivative or a local build, then it's going to be more useful if they can just disable the group by adding a line, and that should reduce the frequency of conflicts when they pull a later upstream version. A control template for a binary package can specify build dependencies that are only apply if that binary package is being built, and then those will be moved to the source control paragraph with those will be qualified by the architecture and build profiles for that binary package. There's also a way of specifying that a binary package will be a dependency for tests if it's built. Again, that will be moved to the tests dependencies with architecture qualification. And I've added, as well as the default filters available as part of Ginger, I've copied lots of extra filters from Ansible that I thought could be useful in this context as well. So, is this ready to use? Well, no, it's not. Part of the purpose of this talk is to attract people to try it out, find out what's missing, and maybe help me with development. So at the moment, it can't do everything that the kernel team's template system can do, although it's gradually getting there. I haven't yet tested it with any other people's source packages, and the configuration schema is not stable. That is subject to change for a while. My hope is that I'll be able to get to a 1.0 release this year, which will be usable for the kernel team and in other packages. And at that point, the configuration schema will be stabilized. From then on, I'm intending to use versioned schemas similar to debhelper compat levels. So if any incompatible changes are added later, they'll be opt-in. So if you have a source package that you think could benefit from a template system or a better template system, there's the debplate repository currently in my personal namespace on Salsa, benh/debplate. Please do open issues and merge requests there. There are things that you want to think should be changed. And with that, I will look for questions.
Yes, I have one question to relay, or rather, I have information from Niels saying, FYI, Debian/templates is also used by dh_install debconf, like d/package templates. We should probably avoid this clash
Yep.
somehow.
Yeah, yes. I think I'm not sure quite how we've avoided that in the kernel package, because we have had debconf templates in there at one point. But yes, which I should probably move everything together into something like debian/debplate, which, as long as debplate doesn't build using itself, should be free.
Okay, one more question. Is it possible to populate variables by output from an external command?
No, but I have an open issue for that.
Okay. One more, another two questions. One is, did you ask the GCC maintainer if they were interested?
Not yet.
That's the next
So
obvious test case.
that's yeah. I don't know if it's
And also, it's not totally clear how to mix these templates between different sources. Can you elaborate?
how
By
to
the way, you've got 3
mix the
minutes left
templates.
officially.
Do you mean sharing templates between source packages?
Sorry?
Does that mean sharing templates between multiple source packages, or I'm not sure I understand the question.
Hopefully the asker can elaborate
Yes.
in a moment. Oh, I do have another question for you. I cannot imagine how this interacts with dpackage-source, or would I have to run some commands beforehand that do the templation?
Yes, that Debian/control and Debian/test control are generated separately from everything else. So there's one command to generate those, which need to be in the source package, and then there are separate commands to generate everything else from templates, and then to clean up the generated files.
Okay, is that everything?
No, I can see as a follow-up from Elbrus clarifying that he did mean sharing between source packages. Right, yeah, that's something I have thought about. But this I can see it would be useful to be able to have some common templates that you share between source packages, but the problem with that is, again, that the Debian/control, Debian/test control need to be generated as part of the source package, and then everything else will be generated at build time. And so if if wherever the common templates come from is updated between preparation of the source package and a build of the source package, for example, as a bin and emulator, then it could be built using an inconsistent set of templates. I can definitely see that this will be a useful thing to be able to do. I just don't know how to avoid that problem.
Okay, I think that's everything for now, right? So thank you all very much for attending.